Welcome to part 1 of Competency 1 quiz. In this video, we will work with properties of real numbers. Number 1, the following 3 steps are applied to a number x. A, the number is squared. B, the result of part A is subtracted from 100. C, the result of part B is raised to the power of 1/2. How does this number appear after step C? Okay, so for step A, it says the number is squared. So that is x squared. And that will eliminate D because of this situation. We have to directly square the x, so that doesn't apply. So then let's look at part B. The result of part A is subtracted from 100. So then the next step is 100 minus x squared. So that must all be together. So that eliminates B. And A is adding, so that eliminates A, and that leaves us C. But let's continue with the fact that it says next, the result of part B is raised to the power of 1/2. Okay. Now, if you don't know your properties, this won't make sense to you. So what this means is it's a basic property, and let me change colors and show you what that is. The first thing that I can say is put it in your calculator and compare. Okay. But you're going to have to, you could put it actually in your y equals, and we'll do that. But I need you to notice something. There is a particular property. If you're not familiar with this, if I have x squared, this really means x is to the first power. Under the square root. Okay. And this actually equals x to the 1/2 power. Okay. Well, how would we test that? All right. This is what we can do. We could do this. We could say under the square root, 4 squared. Okay. We could put a 4. Okay. We don't put a 2 because 2 is understood. Okay. But we put a 3 and a 4. All right. So let me show you what I'm talking about. Okay. We know that that equals 2. So what if we had 4 to the 1/2? What does that equal? And that can kind of prove to you what I'm talking about. Okay. So let's go second square root, put a 4. You know that equals 2. But how about if we had 4 caret up? Now I'm going to go alpha y equals, number 1's what I want, and I'm going to put 1 over 2. Okay, so that's 4 to the 1/2 power. So push equal. They're both 2. Therefore, that is the same. And also, you could, if you haven't seen this before, I'll go ahead and leave it in green. So if I had cubed, right, to the 9, okay, that's 3 times 3 times, no, I don't want to the 9. How about to the 27? Okay, yeah, I was thinking squared. Not going to work. Okay, 27. That is the same thing as saying 27 to the 1/3 power. Now, I could change that even right here. Let's change that. And let's say that I'm going to say 27 squared. Well, that would be raised to the 2/3. Okay. And if you don't know this property, go look it up, and that'll kind of explain things. But anyway, just so you can see that they are the same thing, okay, what we came up with here, let me highlight. What we came up with here and our option C, just put them in y equals and see what happens. Okay, let's clear that out. All right, so in parentheses, I have 100 minus, okay, x squared, okay, and then close your parentheses, caret up, alpha y equals, number one's what I want, then 1, arrow down 2. Now, if I went too fast for you, stop the video, pause, try it for yourself, or just pause here, look at the buttons over here that are pushed, and try it for yourself. You know, it's always best to try it for yourself. Now, I'm going to arrow down. I'm going to put in option C. Okay, second square root 100 minus x squared. Okay, now arrow over. Okay, I need to make sure everything is entered correctly. Now, let's put our graph in whole numbers. All right, if you haven't done this before, I have entered in my y sub 1 and my y sub 2 what I want. But I'm going to say second window. Notice I have it starting at 0 in my table. It says table equals 1. That means it's going to be going up by ones, and that's what I want. I mess with that and play around with it to my needs, so I always double check when I'm going to do something else. So now I have second graph. Okay, notice my pink and I guess that's red, whatever colors I have put in for my y sub 1 and my y sub 2. Notice they are precisely the same. Therefore, what I came up with from the instructions right here, where they said power of 1/2 is exactly the same as being under the square root. So we are correct. We verified this. Okay. Now let's look at number 2. All right, it says, let's scoot up just a smidge. What is a scientific notation for the number 31 over 2? Oh, we get to use the app again. I like that app. Something about it. Okay, so let's go second mode. All right, now we're going to go to our apps right here. Okay, arrow up until, because see how they have kind of extended it where that 0 is. I want SciTools. Now you probably aren't going to have Python, so you'd be minus that Python. It's because you have to buy a separate Python 84. Okay, so and this is a emulator, so it has all the bells and whistles. Okay, all right. So enter when you highlight your SciTools. Okay, you have to enter twice, by the way. Okay, we want option 1 that's highlighted. So push enter again. All right, now, and I made the little mistake and had to catch myself on the last video. So see where it's default to go to decimal. You need to go over to sci. That's your scientific notation right here. So push the trace button. Now it's where we want it, okay? And we do have to use 31 divided by 2. We can't do the fractional setup while we're in this app, okay? It's just not arranged for that. I tried it in the last video just to make sure. Even after I updated my calculator, that capability isn't there yet. Okay, so 31 divided by 2. Okay, and it looks a little funny the way they have it, but it is in fraction form. That's what we want. Okay, and we are in the scientific notation, so push enter. And there it is. Okay, so how to read this if you didn't watch the other video. We need to read this. We need 1.55 first. So any of these that are not 1.55, well, B won't work. Oops. B doesn't work. C doesn't work. D doesn't work. A is the only option. But then you're going to say, wait a minute. What about times 10 to the first power? Okay, that is what this notation means. Okay, so E, now that's a different type of notation. I'm not going to waste your time with it, but you can look it up. Okay, this E, that implies times 10 to the first power. Okay, so anything you have your E and you're going to get a number after, that is what you raise your 10 to. Okay. So that does mean the same thing. So we're good. We're fine. We have verified. Right. So let's look at number 3. Which one of the following is an integer, but is not a natural number? I kind of didn't read that correctly the first time. We want not. What does that actually mean? That means that you want an integer. By the way, integer is notated by Z. Okay, Z is notation for integers. And what you want, not a natural number. So that'll be any negative number, meaning that it's going to have to be not a natural number. So that's going to be any integer less than 0. And I'm saying less than 0 because 0 is an integer, but it's not considered negative. And for our purposes right now, 0 is not a natural number. Be careful with that. In some instances out there in the mathematical world, 0 is considered a natural number. Yes, when you teach middle school, they tell you to tell the kids that 0 is not a natural number. But on the other side of the pond, over there in the European world, in the British, they tell their students 0 is a natural number. And in some college courses, in the textbooks, and in some situations to solve certain number theory applications and write some proofs, you have to say 0 is a natural number. So I am just going to warn you. But for us, we're going to say, that's why I have negative Z there. That's why I have that notation. So let's look at this. Well, we're talking integer. That gets rid of A and D, but not a natural number. Well, 12 is a natural number. So B is the only option we have left. Number 4. Roberta needed to multiply 12 by 4, then multiply that answer by 2. Okay, let's write that down first. So she's saying this first, okay? So 12 by 4. Done first, okay? Then times 12, okay? She decided to first multiply 4 by 2 to get 8. Then she multiplied 12 by 8 to get 96. Well, we have to write that down exactly the way it is said. Okay? So that means we had 12 by, then the parentheses, 4 by 2. You have to put it in the order that's stated. Okay? And yes, this equals 8. Okay, so that satisfies the 12 by 8 equaling 96. Okay, now if for some reason you have got, that's not exactly clear 8, you've got more complex numbers and maybe decimals, something else going on, what you do is you put it in your calculator. And we're going to go ahead and do that. So we have parentheses. We're going to do the left-hand side first. 12 by 4, close your parentheses, times 2. Push enter, 96. Now let's do the right-hand side. 12 times parentheses, 4 times 2, close your parentheses. Make sure I entered it correctly, yes, and push enter. They both equal 96, so everything there is correct. That eliminates A, because A said her answer is wrong because first she should have her answers are correct. So that's going to go away. And then B, it says her answer is wrong. Nope, I disagree with you. Her answers are correct. Okay. C, her answer is correct and she used the associative property of multiplication. I agree with the multiplication, absolutely. And also, it is associative because we didn't rearrange the numbers themselves. What we did is we changed the parentheses showing what we started with first. And if you read the English, it says she wanted to multiply this first. First multiply 4 by 2. Okay, and that would give her 8. So that's just telling us we're not going to flip the numbers around. What we're changing is the parentheses. So that tells me C is correct. Now, let's look at D. Her answer is correct, and she used commutative. The commutative, yeah. Property of multiplication. Okay. What that one is and why it is not the option we need is because she did not flip things around. She didn't flip the position of the numbers. Now, right here, if she had said, let's say right here, if she had said, then, or it had said, she multiplied 8 by 12 and flipped the position of the 8 and 12, then yes, D would have been what we wanted, but that's not what happened in this particular scenario. Okay, so that's verified. So let's go to number 5. Marty claimed that all the negative numbers are less than -1. Which one of the following responses is most appropriate? Well, let's think about this. All okay, negative numbers. Now that means real numbers. Okay, we're including all the negative real numbers, not necessarily just limited to integers. So we're not just saying integers, we're saying the decimals and fractions are in the negatives that we're talking about. Okay, so we're talking about all of them. Negative whole numbers, negative decimals, negative fractions, all of it. Wait a second. If we are on the number line and we start with -1 right here, and we go this way, what are we leaving out? We're leaving out all these numbers from here to 0. Ooh. So that's a whole bunch of numbers right here that are negative fractions, decimals, whichever equivalency you want it, even some irrationals. Okay, we're leaving all those guys out. Okay, so that means A, his claim is completely correct. No, it's not, obviously. Then B, his claim is wrong because some of the numbers less than 1 are irrational. It says negative numbers. They never said something, there was no excluding of irrationals. Now, if they had excluded it and said only the da-da-da numbers or only integers, they're excluding things. So no, that's not why. Okay. C, his claim is wrong because there are negative fractions between -1 and 0. Now, I said that, and I'm gonna be kind of leaning towards agreeing with option C. But let's read option D. His claim is wrong because a negative number always lies to the right of 0 on the number line. Well, there's some truth in that statement, but it doesn't really apply to what he said. We're looking at an appropriate response to his claim. And as you kind of like you're going to respond as a teacher. As a teacher, your natural response should be, hey, what about those numbers between 0 and -1? What about those? Are those positive? So that's what they're trying to get you to see, kind of a teacher view. So D is not one of our options. And yes, it's C, and that's how you respond to the student. Okay, this is the last question in this particular video. There will be another video to complete out the questions for Competency 1. I want to thank you guys for watching, liking the video, sharing the videos, and subscribing to our channel. You guys are the best, and I definitely wish you all happy testing.